You know, every time you click a link, stream a show, or send a message, that data has to travel. But how does it do that? Today, we're going to demystify the silent workhorse of the internet, the router. It's the one device that makes our entire digital world possible, so let's pull back the curtain and see how it really works. I mean, really think about that for a second. You hit send on an email, and almost instantly it crosses continents, oceans, and zips through countless different networks to get where it's going. How on earth does it know the way? Well, that incredible split-second journey is orchestrated by routers. The absolute best way to think of a router is as a digital traffic cop. Seriously, it stands at the busiest intersections of the internet, looking at every single piece of data, your emails, your Netflix stream, your web pages, and in a fraction of a second, it points and says, you go this way, it's the fastest route. So here's our game plan for this explainer. We're going to build this from the ground up. We'll start with what a router's basic job is, then we'll peek inside at the hardware. After that, we'll explore the software that powers it, figure out how it makes those brilliant pathfinding decisions, and then we'll wrap it all up with some must-know security basics. Okay, let's start with the absolute fundamentals. What problem does a router actually solve? What's its job description, really? At its heart, a router is all about connecting things. It connects your private home network, your local area network, your LAN, to the giant global wide area network, the WAN, which, we just call the internet. It acts like an interpreter, so these totally different networks can actually talk to each other. And of course, its most famous job is what we've been saying, forwarding all those little data packets along the best possible path to get them where they need to go. To really get how it does all this, we gotta pop the hood. A router is basically just a super specialized computer. And just like your PC, it has different kinds of memory, and each one has a very, very specific job. First up is ROM, read-only memory. Think of this as the router's deep, primal instinct, kind of like its lizard brain. This is permanent memory that holds the bootstrap program. These are the very first instructions it follows when you plug it in. It's the part that just tells the router to wake up and start breathing before it can do anything else. Then you've got RAM. This is like the router's conscious mind. It's active, short-term workspace. It is incredibly fast, but here's the catch. It's volatile. That means when the power goes off, poof, everything in it is gone. RAM is where it keeps its routing table, which is its live, constantly updated map of the internet, and all the settings it needs to make decisions right here, right now. So you might be wondering, if RAM gets wiped every time you restart it, how does it remember its settings? Well, that's where NVRAM comes in. This is non-volatile, so it holds on to its information even without power. This is where the router stores its startup configuration file, its core identity, its main rulebook, so it knows exactly who it is and how it's supposed to act the second it boots back up. And finally, there's flash memory. The easiest way to think about this is as the router's hard drive. Its main purpose in life is to permanently store the router's entire operating system, the Cisco iOS, for instance. This is the complex software, the actual brain of the device, that makes all this hardware come alive. And speaking of the brain, let's talk a little more about that operating system. Your laptop is just a metal box without Windows or Mac OS, right? Well, a router is just a box of circuits without its own special OS. And believe me, not all router brains are created equal. This table really shows how these operating systems are built for different jobs. Look at the classic iOS. It's monolithic, kind of a self-contained unit, perfect for traditional networks. Then you've got iOS XE, which is built on a Linux foundation, making it way more flexible for modern networks that mix wired and wireless. And then for the huge, beastly routers at the core of the internet, you have iOS XR. It's the difference between a family car, a heavy-duty delivery truck, and a Formula One race car. Each one is a specialized engine for a specific purpose. All right, we've seen the hardware and the software. Now for the really cool parts, the magic. How does the router actually decide where to send all your data? This whole decision-making process is run by a set of rules we call routing protocols. Now, this is a super important distinction, so pay attention here. Routed protocols are the data packets themselves. Think of them as the cars and trucks on the highway. Routing protocols, on the other hand, are the rules of the road. They are the traffic signals, the GPS, the traffic cops, things like OSPF and EIGRP that tell the cars which way to go. One is the what, the other is the how. It's a critical difference. So, there are two main ways to build that roadmap. First, there's static routing. This is where a network admin manually programs every single route. It's like giving a driver a printed map. It's simple, it's secure, but if there's a traffic jam or a road closure, well, you're stuck. Dynamic routing is the modern way. This is where routers talk to each other and learn the network automatically. It's just like using a live GPS app on your phone that reroutes you in real time if there's an accident up ahead. Now, inside dynamic routing, there are different ways of thinking. The oldest strategy is called distance vector. It uses one very simple metric: how many hops, or other routers, are between here and the destination. The path with the fewest hops wins. It's kind of like choosing a driving route just because it has the fewest toll plazas, even if it means you're stuck on slow country roads the whole time. A much more intelligent way to do things is with link state protocols, like OSPF. They look at more than just the number of hops. They look at the cost of a path, which is usually based on how fast the connection is. This is like a GPS that calculates the fastest route using actual highway speed limits instead of just counting the exits. Much smarter. And then we get to the really sophisticated stuff, hybrid protocols, like Cisco's EIGRP. These take a best-of-both-worlds approach. They combine a whole bunch of metrics: bandwidth, delay, reliability, network load, to make a decision. This is the ultimate GPS, the one that's factoring in speed limits, live traffic, road quality, and everything else to find the absolute, truly best path for you. Okay, this next part is critical. Because the router is the main gateway into and out of our network, it is also our frontline security guard. So locking it down isn't just a good idea, it is absolutely essential. One of the single biggest security holes in older networks was using Telnet to manage them remotely. And why is it so bad? Because it sends everything, and I mean everything, including your username and your password, in plain, unencrypted text. Anyone listening on the network can just snatch it out of the air. The modern secure standard you should always use is SSH, or Secure Shell, which encrypts the entire conversation. Setting up SSH isn't that complicated, really. It's a few key steps. First, you give your network a unique domain name. Then you create a local user account for people to log in with. Next, you generate the special encryption keys that make it all secure. And finally, you tell the router to only allow SSH connections for management, which basically slams the door shut on old, insecure ways in, like Telnet. And here's another super simple but really powerful security tool: the Message of the Day banner, or MOTD. This is just a little message that pops up before anyone can log in. Think of it as a digital no trespassing sign. Now, it's not going to stop a determined hacker, but it sets a very clear legal warning and tells unauthorized people to back off, which can actually be super important from a legal standpoint. So, from its physical memory and its operating system to the complex rules it uses to navigate the vast internet, the router is just an incredible piece of engineering. The next time you send an email or stream a video without a single thought, maybe just take a second to appreciate the millions of tiny, lightning-fast decisions being made by these invisible traffic cops, all working around the clock just to keep our digital world connected.